Alright, here we go. Just a continuation of the last video on relations. And of course, yes, we're talking about this word functions. And with functions in the last video, relation, remember here was the simple definition of what a relation was. It's a mapping or pairing of any input values with any output values without any restrictions whatsoever. None. A function is a much more specific relation. And here's what I'd recommend running into. There's two definitions, but here's the first one. It's the book definition of what a function is. You need to write it in your graphic organizer. A function is a relation provided there is exactly one output for each input. So it's a specific type of relation. We're not just pairing any old thing. It has to be specifically where one output is going for each input, or is coming from each input. Here's how I like to say it. You're going to see me say this a bunch in class and even throughout these videos. Here's what a function is to me. It's a rule, some type of a rule, mathematical rule, that takes any input value, of which last video we know we called domain, the input value over here, the input value, or the x-coordinate over here, whatever it is, and it pairs it with exactly one output value, what we call the range, or the y-coordinate. So whatever the rule actually is, it takes that thing over there on the left, input, whatever it is, does something to it, that's what the arrows mean, and outputs one particular thing. So you cannot have a situation where an input value is being paired with two things, or three things, or four, which you'll see some examples here very quickly. So jot this down in your notes. I think there's a section there for it. If not, make it. So we have a mapping diagram here, and here's a simple rule. Well, the question, of course, it just pops up, is this a function or is it just a regular relation? Well, if I take a particular rule, we don't necessarily know what the rule is, but we could figure it out. If I'm taking an input of 4 and it's going to output to me a 12, or I input a 2 as an x-coordinate and it's going to output to me a 6, or I take an x value of -1 and outputs a -3, or 0 gives me 0. I don't know if you see the rule or not, but if I had an x value over here, the rule is actually I'm taking 3 times whatever the x value is. That's the actual rule. So my input value of 4, I take 3 times it, get a 12. My input value of 2, I take that times 3, I get a 6. My input value of -1, take that times 3, I get -3. So my rule here is 3 times whatever my input value is. So my domain is anything here that I can put in. My range is what it gives me out, legitimately. Okay? But here's the scoop. As you see, each input value is being paired with exactly one output value. That is absolutely a function. So that is a very, very good function. Yippers, it absolutely is. How about this one? What if I take these input values now and I say the rule looks like this? So 3 is being mapped over here to 9, -1, and also 1 are being mapped to my range value, my y value of a 1, and 2 is being mapped to 4. Now once again, doesn't necessarily matter this, but check this out. These being my x values over here, these being my y values. If I'm looking at the rule, I'm actually taking my input value, my domain numbers, 3, -1, 1, and 2, and I'm actually squaring it. That's the rule. So 3 squared gives me 9, -1 squared gives me 1, 1 squared gives me 1, 2 squared gives me 4. Regardless though, this, is it a function or is it not? Well, is each input being paired with exactly one output? Yes. This input's only going to 1. This input's only going to 1. Now I know this. Both of these x values are being mapped to the same one, but it doesn't matter. It's okay. That is absolutely a function. Absolutely a function, because each input value is being paired with only one output value. Or the other way around, each output value is coming from only, if you will, one input. You're like, what? Let me give you another example. So this one, absolutely, you betcha, is a function. Check this one out. So here's my arrows. Now, the rule doesn't matter. In fact, I don't know. I just made this one completely up. But let's say 7, my input value is being mapped to 5. -3 is going to -1. And also 3 as an input value is going to 3. And then 1 over here is going to 4. Well, is this, again, a function? The answer is no. It is not a function. Why, Motter? You're crazy. Why? Because each input value, yes, the 7 is being mapped over here to the 5. That's beautiful. But the problem is right here. -3, that input value is being mapped to 2 different output values. It's trying to go 2 different places. Can't do it. That is not a function. It certainly is a relation, no doubt, but it is not a function. Now, you might be sitting there thinking like, what in the world? I'm a little confused. Well, go back and watch it again. Listen to the words that I'm telling you. But here's a simple example. And I'll relate it to you this way in terms of our school. Let's say that you get up in the morning. There's 4 different people. I just make this up. Let's say one is Frank, Sally, Harry, and the guy that's always late, Mark. Whatever, it doesn't matter. So let's say that they get up in the morning and they're all coming to the high school. I don't care how this person comes to the high school. Doesn't matter if they come in a bus or she comes and rides a bike, or the little guitar man here walks to school. Of course he would. And the guy that's late gets in a big old race car and gets to school. Doesn't matter. Is this possible? Absolutely possible. Listen, every single day, guys, this is exactly what we all do. We all get up at different places in the town, you know, in different boroughs, wherever we are, but we all come to the same place. It happens every single day. People come from different areas and they go to the same place of work. Wherever you work, people live in different areas. They all come from different areas. Teachers, some of us don't even live in the town we teach in. We live pretty far away, some of us, but we all come to the same spot. It's perfectly fine. That's an example of a function. Even though all of these input things over here, people, numbers, whatever, are coming to the same place, it's okay. That's why, by the way, this one was a function. Now, let me give you this example. Let's say you get up in the morning, you're like, you know what? I'm going to do this. I'm going to go to the high school. I'm going to go to Mechanicsburg. And at the same exact time, I'm going to go over to Trinity. And at the same exact time, I'm going to hit up CV. Now listen, you could do those 3 things in a day, but you can't do them simultaneously. So you cannot be mapped. You cannot go from one input value to 3 other places. Can't do it. That's why it's not a function. That's why this one right here is not a function, because this -3 is trying to go 2 different places. Can't do it. Impossible. No doubt it's a relation, but it's not a function. Okay?